Welcome back, everyone. In today's lesson, what we're going to do is review for applications of the derivative that require your chain rule. In addition, you should be preparing for your test. So let's get started. As you prepare for your test, I want you to think about what you need to review. Do you know the definition of the derivative? Have you worked on continuity and differentiability? Do you have all of your basic derivatives memorized? And do you know those product and quotient rules? Today, we're going to practice a little bit more of the chain rule to strengthen it, but you must have those basic derivatives. So make a list of things that you need to work on. So let's take a look at example 1. We're expected to determine the derivative of this very complex function. We want to really understand the inside parts and the outside parts of this problem as you look at your composition of functions. So I'm going to rewrite it so that we understand the cosine is the outermost composition. Inside, as the angle, you have a sine, which has a tangent, which also has a pi x. And I'm going to close all the parentheses related. Now, the parentheses are going to help guide my work. I'm going to take the derivative of the outside, so y prime is going to be equal to the negative sine. We keep everything that's on the inside. So we have the angle, so we haven't touched it. There's our sine, our tangent, our pi x, and we keep that to the 1/2 power. Now let's examine it again. The 1/2 is now part of the outer shell, and the derivative of a function using our power rule is 1/2. And we're going to keep the inside again raised to the negative 1/2 power. And as we keep the inside function, we have the sine with a tangent at its angle, and the tangent's angle is pi x. All right, so once again, we're going to examine what's happening. And the outermost part that we have left in our problem is the sine again, and the derivative of the sine is going to be cosine. So we're going to multiply by the cosine, and once again, keep that inner part of the function, which is our tangent and pi x. And now we look at the derivative of the tangent, which is your secant squared. So we have a secant squared, keep the angle, pi x. The derivative of the angle is pi. So while this is quite a complex problem, using the chain rule can work smoothly if you really understand the composition of functions. For our second example, we're going to evaluate f of x at a point. Now please recall, you have to find the derivative before you can substitute your value in. In particular, let's look at f of x and rewrite it so that the algebra might be easier for us to handle. We'll have x squared minus 3x to the negative 2 power. So our derivative, f prime of x, using our chain rule, is negative 2, keep the x squared minus 3x, subtract 1, which gives us a negative 3, times the derivative of the inside, which must be in parentheses, 2x minus 3, since it was a binomial. We're now looking for f prime at 4. Complete your substitution, you end up with negative 2, 16 minus 12 to the negative 3 power, and then we have 8 minus 3, which of course is 5. Simplify just a little bit more, and you end up with your negative 5 over 32. All right, now the second part of this example, we're going to practice using the graphing calculator. So get your graphing calculator out now while I get set up. For the graphing calculator, we want to first fill the function in for y1. So let's take a look at the video as you walk through. We substitute our function y1 equals and put the simplified version of the function in. You have your quantity x squared minus 3x to the negative 2. Now, once you have your function placed into your placed in for y1, we want to make certain that the window allows for x to equal 4. So check your window. We have the x min at -10 and the x max at 10. If you need to zoom standard, you can. Take a look at your picture. As long as x is equal to 4 is part of the value, you're all set. Choose dy dx, and once you have your dy dx chosen, just type 4 and hit enter. The derivative will show up on your screen. There's our -0.15625, and you also have the x and y value provided. So make certain that you can find a derivative using your calculator, as well as finding the derivative by hand. The next two problems were specifically chosen so that you could practice some of your algebra skills when it's time to simplify your derivative. Once you've completed the problems, also practice using your calculator to check that derivative. Turn the video off now, practice the problems, and then check your answers. All right, so check that you've used your chain rule correctly. Then recall how to multiply by a factor, which will eliminate your fractional exponents so that the problem is simpler to solve. And make certain that you've actually answered the question, which is write the equation of your tangent line. Notice all the notation. I'm finding a derivative, and then I've substituted the 2 into the derivative so that I now know the slope of your tangent line at one particular point. The second question is done in a very similar fashion. And take a look at the answers here. But what I wanted to also point out is a different way to find your derivative. So let's take a look at this other little video so that we can look at derivatives without using the graph. So first, place your function in for y1, just as you did before. This time, we're not going to worry about a window setting. That's going to make things a little bit easier for ourselves. So we're going to go back to the home screen. So second, quit. We're now at the home screen. Go to Math. Choose Numerical Derivative. That's number 8. Write the derivative with respect to x. The function is vars, y-vars. Choose y1 because that's where you placed your function. And I'm typing in x equals 4. If you want to check the one you did, type in x equals 2. So that's a separate way to find a numerical derivative using your calculator. All right, now complete the rest of the worksheet. You've got questions 3 through 7 to complete, and then you can check your answers once you're finished. The answer sheet is on Schoology, and you will find it listed under completed notes. All right, so now it's time to prepare for your second test. Make certain that you have a good understanding of your basic derivatives, know the definition of your derivative, know about differentiability, continuity, and have an excellent grasp of your product rule, chain rule, and quotient rule. All right, you have a fabulous day.